Question number one. This question is about periodic table. It is an AO2 question. 1.1. Figure number one shows the part of Mendeleev's version of the periodic table. This question is from the development of the periodic table. A sample Mendeleev periodic table is given here. I try to elaborate my figure number one. In Mendeleev's periodic table and comparing with the modern periodic table, it looks like group number one, group number two, or group number three, 4, 5, 6, and 7. If you look here in the question is which group of the elements had not been discovered when Mendeleev's version of periodic table was published. It is a sample periodic table developed by Mendeleev. At the time of the Mendeleev, the noble gases were not discovered. Noble gases were discovered by the end of 19th century, whereas Mendeleev's periodic table was developed in 1869. There was no concept of noble gases at the time. So the group of the elements which was not discovered when Mendeleev's periodic table was developed, that group is noble gases, or group number 0. Figure number 2 represents different models of atom A, B, C, and D. 1.2 is an AO2 question. Which model represents the Plum pudding model? This question is from the development of different atomic models. The student must know about the plum pudding models and they need to apply the knowledge to figure out which figure is representing the plum pudding model. The concept of the plum pudding model is that atom is like a sphere, which is positive charge sphere, whereas the negative charge particles means electrons are embedded on different places of that sphere. If you look here in figure number A, it is not a positive charge sphere. If you look figure number D, it is not a positive charge sphere. If you look C, is a black sphere with no information. If you look into number B, this is a positive sphere and negative charge electrons are present at different places. So the correct answer is B. 1.3 is an AO3 question. The student need to apply their knowledge and need to figure out which figure is giving the correct information about Chadwick's experiment. Which model resulted from Chadwick's experiment works? This question is again from the topic of the development of different atomic models. The Chadwick's experiment is related to the discovery of neutrons, and the neutrons are present in the nucleus, and the nucleus is combination of both protons and neutrons. Let's see the figure number 2. B is related to plum pudding model. C is a sphere or atom with no information. If you look D here, there are 4 electrons and 4 protons are present there. There is no information of the neutral particle. But if you look the model A, there are 4 positive charge particles or protons are present in the center. There are 4 negative charge particles are present outside, whereas the other particles are also present in the center having no charge. So this model A represents the combination of positive charge particles and the neutral particles in the center, which is called nucleus, which shows that these particles are actually neutrons. Chadwick experiment is related to discovery of neutrons. So the model answer is A. Potassium has different isotopes. 1.4 is an year 1 question. The student must remember the definition of isotopes. What is meant by isotopes? You should refer to subatomic particles. So this question is from the concept of isotopes. The students must know the definition of isotopes. Let's see the model answer to explain this question. In the model answer, we have potassium 1939, another potassium atom 1941. If you look here, we have 19 and 19. Both are atomic numbers. And atomic numbers mean number of protons. So both of them has 19 protons. But if you look here, the mass number is different. One has 39, another has 41. If you want to find the number of neutrons, we need to subtract 39 minus 19. There are 20 neutrons present in this potassium. But if you subtract here, we have 22 neutrons in this potassium. So number of neutrons are different. One has 20 neutrons, another has 22 neutrons. One has 19 protons, another also has 19 protons. So number of protons or atomic number is same, but mass number is different. Or we can say it has same number of protons but different number of neutrons. Both are atoms of potassium because potassium has the number of protons 19. If we need to recognize an element, we need the atomic number, not the mass number. So both of the particles, or both of the atoms, they have the atomic number 19. So it is potassium atoms. We can see here the number of protons are 19. Let's see the model answer. Atoms of the same element having same number of protons but different number of neutrons are called isotopes. Atoms of the same element having same atomic number but different mass number. 1.5 is an AO2 question, and table number 1 shows the mass number and the percentage abundance of two isotopes of potassium. This question is from the topic of relative atomic mass. The masses are given, like potassium with the mass 39, its abundance is 93.1, whereas potassium 41, its natural abundance is 6.1%. Calculate the relative atomic mass of potassium. We need to find the relative atomic mass of potassium. Give your answer up to one decimal place. Let's see the formula which is needed to find the relative atomic mass, and we need our answer up to one decimal place. Let's see the model answer. Relative atomic mass of potassium, which is represented by AR, is equal to sum of isotope abundance multiplied by isotope mass number. So this is the percentage abundance times by its mass. And we need to add them together. Divided by sum of the abundance of all isotopes, sum of the abundance of all isotopes. Students need to remember this formula. This formula will not be given to the students in the real exam. So 39 multiplied by 93.1 plus 41 into 6.9 over sum of the abundance. If you use a calculator, we will get the answer 39.138. But the demand of the question is we need our answer up to one decimal point. So up to one decimal point, we have the answer 39.1. Because after one decimal point, the number is less than 5.